right, IVAISL2. Today we're doing section 3.3 and we're going to be talking about different ways to present data. So this first example is that a zoo is open for 365 days, or 360 days a year, and the number of visitors each day was recorded and displayed in different ways. This first one right here, we're going to be working with a little bit today, and this is called a histogram. One of the main features of histograms is that they contain these bars of interval data. Please notice that the bars touch each other, that there's not any gaps. Like some people see graphs like this and they think that they're histograms, but that's something, it's a completely different type of chart. It's not called a histogram. So when the bars touch each other and it has continuous data, that's called a histogram. This next one, gosh, there's a couple different things you could call it, but I think we're just going to call it a pie chart. Why is it a pie chart? Looks like a delicious pie, doesn't it? Start calling them pizza charts. Then there's two more down here. This one is called a box and whisker plot. Notice that it has a box right here, and then it has whiskers that come off to the side, like a little kitty. This one right here, we're not going to get too deep into today, but it's called a cumulative frequency polygon, I think is what, or cumulative frequency graph. I've seen different texts call it different things. But cumulative frequency polygon. First example, this coach takes all these times of students running this 100-meter run. All of the times are in seconds. And then he split it up into boys and girls. So this first column is girls, second column is boys. Now, there was raw data in the beginning of just like actual times for them, but he separated them into intervals. So this interval is anybody who ran it between 11 and 12 seconds. This is between 12 and 13, 13, 14, all the way up to 22 to 23. So that was like the longest time it took for somebody to run the 100-meter dash. This cumulative frequency... just frequency table is kind of uncomfortable to look at the data. I think a way better way to look at this would be a histogram. So what you do with a histogram is all of these right here, your actual data scores, this is going to be your x-axis. Then the frequencies, these are going to be your y-axis. So you have to decide, like, what's the biggest score that anybody got in terms of frequencies. I think the biggest ones out there are 10. So the y-axis has to go up to at least 10. The x-axis has to start at 11 and go all the way up to 23. Here's the two sets of data in two separate histograms. Notice that the girl data doesn't start until 13 to 14. If you go back to 13 to 14, which is this column, or this row right here, that was the first time there was data, because here it was 0, here it was 0, and then there was two people in the 13 to 14. So if you look here, between 13 and 14, it's too tall. Then from 14 to 15, it's 5 tall. If you go back up here, notice from 14 to 15, there was 5 girls that ran between 14 and 15 seconds. So you just continue like that. So each time, like, this is your frequency of how many people ran it. So this tells me that 8 girls ran between 15 and 16 seconds. I also see between 19 and 20, there's a gap. That means that no girls ran it between 19 and 20 seconds. which I think is confirmed with the Yeah, you can see that in the table right here. There's a gap. So that's how you build histograms. So these are histograms. Now, you can look at these and be like, okay, what does this tell us? Like, there's a lot of things you could take away from this. Some students will talk about this right here and say, well, that looks like an outlier. A lot of people are quick to throw out that word outlier. But then I always ask, like, well, okay, an outlier is something that's away from the bulk of the data. But how far away does it have to be before it's an actual outlier? Like, if I was to take this and scoot it, like, to this spot right here, is it still an outlier? And people are like, well, yeah, maybe kind of. You know, if it's over here, people are like, oh, definitely an outlier. But then, like, how close does it have to get before you're like, well, I'm not sure if it's an outlier. Luckily, math has a way of figuring this out. Outliers are any data point that is smaller than the lower quartile minus 1.5 times the inner quartile range, or greater than the upper quartile minus 1.5 times the inner quartile range. Remember, LQ is lower quartile, UQ is upper quartile, but other books call this Q1 and Q3. The inner quartile range is the upper quartile minus the lower quartile, or Q3 minus Q1. Now, our last example is data on the shoe sizes of a group of students shown in the table. Notice that the sizes are on the top row. If these sizes look like gigantic feet, remember that this is an IB curriculum, so those are British shoe sizes probably. I see it's males versus females. To be able to draw and box and whisker plot, which box and whisker, by the way, was this guy up here. To do a box and whisker plot, you need the 5-number summary. We're going to be doing this with technology. So I'm going to plug all of these numbers into list 1 in my calculator, all of these into list 2, and then these into list 3. Then you can check out my other video about running 1var stats to find the 5-number summaries. So if you run the 5-number summary just for females, the 5-number summary is 34, 37, 38, 39, 40. Now, if you forget what the 5-number summary is, this is your min, the smallest shoe size. This is your max. This is your median. And this is the lower quartile. And this is the upper quartile. If I, do we have to run the bounds? Oh, they do check. Okay. For this data, for the female data, we're going to state that the IQR is equal to 39 minus 37, which is 2. And then we're also going to check where the bounds are to see if there's any outliers in the data. So, LQ minus 1.5, that's a 1.5, times the IQR is 37 minus 3, or I guess it was 37 times 1.5 times 2, which is 34. Then the upper quartile minus 1.5 times the IQR is 42. So remember that if there are outliers, they would be below 34, which there's none, and anything above 42. But notice there's no girl shoe sizes above 42. Now, let's do all that same thing, but for the boy data. So you're going to punch it all into one var stats. Man, I'm going to run out of space. Okay, we're going to have to move that. For the boys, the 5-number summary is 37, 38, 39, 40, 49. The IQR is 2. And then the lower quartile minus 1.5 times the IQR, remember checking for outliers, is 35. And then upper quartile minus 1.5 times the IQR is 43. That should have been a plus. Yeah. Now, does that mean that there's any outliers? Oh, yeah, look. The top for boys is 43. So look at this 49 right here. That's an outlier because it's past 43. Now, there's no boys below 35 because 35 was like the lower bound, but there's nothing over there. Okay, so let's take this, scoot down a little bit. So for the girls, the smallest number is 34. This is where you put the first part of your whiskers. So here for girls, we'll do a different color. So we put a dot on 34. Then the 37 is the lower quartile, and that's where you're going to put a vertical bar. The median is 38, so we put another bar. The upper quartile is 39, so that's another bar. And then the max is 40. So you put another whisker. Then you connect your box, put lines on your whiskers. So this is the girls. That's their box and whisker plot. Now for boys, the min is 37. So we'll do it right here. Then the lower quartile is 38. Then 39, then 40, then 49. Now, just a quick note about quartiles. What this means is that 25% of the data falls between the dot and the first quartile. So that's like between 37 and 38 is 25% of the data. But that's true of all these spots, that this is also a 25% chunk, this is a 25% chunk, and this is a 25% chunk. Now I realize you're looking at that and you're like, well, all of those aren't the same distance, but that's true. It's just that with this upper half, or the upper quarter, I should say, it's a lot more spread out, as opposed to the first 3/4 of the data were a lot more clustered. Now, let's see, are they gonna, yes. Because we checked for outliers with the boys, and anybody over 43 was an outlier, that means that the 49 was an outlier. So, technically, this is an outlier, and it shouldn't be the end of the whisker. So, what we're gonna do is get rid of that and put a star, an asterisk. Then the end of your whisker is going to be the next data piece over. So because we're not including the outlier, the next boy data is a 42. So then we put our whisker on 42. Okay, you guys, your homework is 3F. Good luck.